This problem asks us to find and simplify the difference quotient for a given function. Let's start by recalling what we mean by the difference quotient, or where it comes from. If we have some general function, let's say g, then the difference quotient comes about just from a generalized version of finding the average rate of change. Instead of working with particular x values, we work with generalized x values, namely a variable x, and then an x plus h, where h is just some small number. Okay? And so what we want to find, if we're finding the average rate of change, we are just going to find the slope of the line through those 2 points, the slope of the secant line, as we call it, through those 2 points. Well, the coordinates of this point is just x plus h, g of x plus h, and the coordinates of that point, x, g of x. So if we find the slope of this line by taking the change in y over the change in x, or the change in the function value over the change in x, then this formula, this difference quotient, pops out. Okay. So now that we understand that this is just a different way of thinking about the average rate of change and a general way of thinking about it, let's go ahead and compute this difference quotient for the given function. Okay, well, we're going to start by just taking this expression and making appropriate substitutions into the function that we're working with. If we want to find f of x plus h, right, the x plus h, the entire expression here is inside these parentheses. That's telling us to take x plus h and substitute it into our x. So that's 2 times x plus h, that quantity squared, minus 8. And this is just f of x plus h. And we're going to subtract f of x and divide the entire expression by h. Now, because we are working with a very nice function here, what we call a polynomial, things are going to work out very nicely. Right? The game plan from here on out is to simplify this expression so that we can cancel this h out of the denominator. So I'm going to start by expanding this x plus h squared. And again, remember that's x plus h times x plus h. So when we distribute, we get x squared plus 2xh plus h squared. And I'll leave the rest alone for the moment. And then we'll go ahead and distribute the 2 over this expression and the negative 1 over that last expression. So after we have expanded out this numerator completely, we see that any term that does not have an h in it is going to cancel, right? We have a positive 2x squared, a negative 2x squared, so that becomes 0. A negative 8 and a positive 8, so that'll become 0. And we are just going to be left with the terms involving h's. When we work with polynomials like this, we expect that to happen. Okay, so after we go ahead and simplify that numerator, we are left with 4xh plus 2h squared, all divided by h. And we can see that we're going to be able to cancel out this h because h is a factor of the numerator. Right? We have an h in both of these terms, so we can factor it out. And after we factor it out, we can cancel these h's, and we're left with 4x plus 2h.